The LTC2000-16 is a 16-bit, 2.5 gigasample per second current steering DAC with excellent spectral purity. It can be used in various applications for signal generation where a low noise floor and high spectral purity are important. With 40 milliamps of output current, the LTC2000 offers flexibility in output impedance. Its low additive phase noise makes the LTC2000 ideal for demanding communication systems where maximum performance is critical. The LTC2000 provides the performance and flexibility to be used in any demanding signal generation application. Every DAC requires 4 things: power, input data, an output network, and a clock. The LTC2000 has 5 voltage rails that dissipate 2.2 watts at full sample rate. The input data from an FPGA can either be single-lane or dual-lane DDR LVDS. Linear Technology provides FPGA code and reference designs on how to write code for the FPGA. The analog output performance of the LTC2000 is unmatched. The noise spectral density is better than 158 dBc per megahertz up to 500 megahertz. It also has spurious-free dynamic range better than 74 dB up to 500 megahertz and better than 65 dB SFDR for output frequencies up to 1 gigahertz. The LTC2000 has industry-leading spectral purity, beating the competition by nearly 20 dB across a wide range of frequencies in both single-lane and dual-lane operation. The excellent spectral purity of the LTC2000 relaxes the requirements of output filters and ultimately improves the performance of the system. The LTC2000 can be used from 50 megasamples per second up to 2.5 gigasamples per second. The high-speed clock for the LTC2000 needs to have low phase noise for maximum performance. Linear Technology offers the LTC6946, a high-frequency synthesizer that provides a clean, flexible clock solution for the LTC2000. The LTC6946 can produce signals from 370 MHz up to 5.7 GHz without an external VCO. It has excellent phase noise performance and very low spurious content, making it an ideal candidate to clock the LTC2000. The LTC6946 will accept reference frequencies from 10 to 100 MHz. It can drive the LTC2000 directly without filtering to produce datasheet performance from the LTC2000. Here we see the LTC6946 driving the LTC2000. With simple blocking caps and 50 ohm termination, a low phase noise clocking solution is achievable with the LTC2000. The results speak for themselves. Here is a plot of the phase noise of the LTC6946 and the LTC2000. The additive phase noise of the LTC2000 is almost undetectable. As good as these results are, if ultra-low phase noise is required, the LTC6945 can be used with an external VCO to reduce the close-in phase noise even further. As a default, the LTC2000 has 40 milliamps of output current, but this can be adjusted from 10 milliamps up to 60 milliamps by simply changing the value of an external resistor tied between FS adjust and ground. Internal registers can also change the output current between a minus 10.8 and 14.3 range in steps of 0.4%. The DAC output wants to drive a low impedance, as low as possible in fact, by using external termination resistors in conjunction with the internal 50 ohm impedance. A low impedance is obtainable for best performance. If a higher impedance is required to drive the spectrum analyzer or a 50 ohm system, series resistors can be used to pad up the output impedance. Terminating the DAC with a higher impedance will cause a larger signal swing, but the performance of the DAC will degrade. The output spectrum of the LTC2000 speaks for itself. With a clean sampling clock produced by the LTC6946, the excellent performance of the LTC2000 is suitable for the high-speed communication and signal generation applications. The LTC2000 also has various additional features such as internal pattern generator, LVDS loopback, and junction temperature sensing, simplifying system development and testing. The LTC2000 is part of a family of DACs that includes 16, 14, and 11-bit solutions. The demo board and reference designs are currently available at linear.com. This is Clarence Mayott. Thanks for watching.